All right, friends, welcome to the notes for 4.1, translations. We blast off into chapter 4, transformations. And what's that going to look like? Well, we're going to get a little help from our old friend GeoGebra. So, follow these steps as I complete them with everybody. So we're going to open up GeoGebra. So here we are. Start your calculator. And this exploration is telling us to go ahead and sketch a polygon. So you got to go down to more polygons at 1, 1, 2, 3, and 5, 2. Oops, not quite on 5, 2 with this point. So I'm just going to drag it to 5, 2. Okay, now, next we want to translate or slide this thing. So to do that, we need a new function. Under lines, you'll see vector. So go ahead and highlight vector. We want to put the vector from 0, 0 to 7, 1. So we're going to talk a little bit more about a vector here when we get into our notes. But right now, just know that that's what we need. And then chapter 4 is full of things from this category here with transformations. And the transformation that we are performing first here in the first section is a translation. So we want to translate by vector. So then once that comes up, click on the object you want to move and then click on the vector to tell it where to go. So translation by vector, click on the triangle, then the vector. So this entire figure moves 7 units to the right and 1 unit up. All right, so now that's the gist of it. The lesson, let's get into the semantics of it and see how we're going to refer to these things. And to get the party started, we have a vector. By definition, it's a quantity that has both a magnitude and direction. It's represented by an arrow. And when you guys take physics, pre-calc, you'll be dealing a lot with vectors. Here's an example of a vector, P to Q. And this vector goes 5 units to the right and 3 units up. You can always tell the initial point is the point that doesn't have the arrow on it. Initial starting point, of course. The terminal is where it terminates or ends, and that's where the arrow is. So this vector starts at point P and goes to point Q. So now what did it do? Well, it went 5 units to the right and then went 3 units up. So therefore, its components are 5, 3. If it would go to the left, it'd be negative. And if it would go down, it'd be negative on the Y. So always put the left, right shift first, the up, down shift second. Component form 5, 3. At the bottom here, a transformation is a function that moves or changes a figure in some way to produce a new figure called an image. So what you start with is called a pre-image, the original figure, and then where it goes is called the image. And our first type of transformation that we focus on in this chapter is a translation. And maybe your middle school math teacher called it a slide. That's what we're doing here. We're sliding. It doesn't have to be a triangle. In this example, it is a segment. We are sliding a segment, a certain amount to the left and right, and a certain amount up or down. And really, you're just going to focus on what is changing to your x and y from each one. Now you see the little dashes, the little apostrophes? That is P prime, and that is of the image. So the pre-image is just going to be PQ, and then the image will be with primes. Now in the first example, we are identifying vector components. So I got this vector, starts here at J, goes up to K. So to name it, we would just call it JK, its starting point to its terminal point. And then in component form, what does it do? Well, it goes 1, 2, 3 to the right, 2, 3, 4, up. So 3, 4. All right, translating the vector. So now you guys can practice using GeoGebra here. And let's see what we got. Let me start new. And so we are 0, 3, 2, 4, 1, 0. 0, 3, 2, 4, 1, 0. 0, 3, 2, 4, 1, 0. So here's our triangle. And we want to translate using the vector 5, negative 1. So let's go back to vector, over 5, down 1. And down to transform, translate by vector. Let's click on the triangle and the vector, and we have new points. So A prime, we have 5, 2. So A prime is 5, 2. B prime is 7, 3. And C prime is 6, 0. All right, now you could also just look and apply this to each of these. So we get to add 5 to the x's and subtract 1 from all the y's, and that'll get you where you need to go as well. And I messed up and I didn't put it at 1, 0, so let me just move that. So 1, 0, there we go. And you can see how it affects our C prime. All right, so that's how I checked myself. I'm like, oh wait, I have to go down 1 and I didn't go down 1, so now it's all down 1. All right, friends. Now, the second part of the section, we can also use a rule, not just component form, but a rule to translate something. So you just look and see what happens to x, what happens to y for all the points. So in this problem, a rule, let's see, A is going 1, 2, 3, 4 to the left and up 2. So in vector form, 4 to the left and up 2 looks like that. But now as a rule, we want to say x, y maps to x minus 4, y plus 2. All right, that's simple. So this and this mean the same thing, it's just in a different form. Translating the vector in the coordinate plane. So now you can either use GeoGebra or you can apply the rules. So in this case, we want to add 3 to the x's and subtract 1 from the y's. And that leaves us with this scenario. So all these x's got added 3, add 3, add 3, add 3, add 3. And the y's subtract 1, subtract 1, subtract 1, subtract 1, subtract 1. Monitoring our progress. Go ahead and pause the video here, pick it back up. All right. Name the vector. Well, it starts at B, goes towards K, so BK. And then its component form, 1, 2, 3, 4, 5 to the left, and up 2. All right. Now, in number 2, we want to apply this rule. So we want to add 1 to all the x's. So R prime would be 3, and then add 2 to the y's, so 4. S prime, add 1 to the x and 2 to the y. and then t prime, add 1 to the x, and 2 to the y. All right, and finally today we have rigid motions, which rigid motion, or another word for that is an isometry, is just basically you're moving the figure, you're not changing its size or shape. In this section, we're sliding it. Later, we're going to flip it and spin it, but right now we're just sliding it. And since we don't change the angle measure or the segment length, then it's called an isometry or a rigid motion. Now, two or more transformations are combined in a single transformation. The result is a composition of transformations. And compositions of transformations are also rigid motions. We're not going to change the size or shape, we're just moving it around. So for instance, we have a segment here, we move it once, and then we move it twice to be here. That's a composition. And so, like I said, it is indeed still a rigid motion, an isometry. So the last example, in this case, we're taking this segment RS, and we're going to do two things to it. First, we're going to move it 5 units over and 2 units down to get here. And then we're going to move it 4 units to the left and 2 units down from there to end up at the points double prime. So the first was just 1 primes, and then our second move, we get a double prime. All right, on this last monitoring progress, you don't have to use GeoGebra. We can just apply it. So go ahead and pause the video and see what you get. All right, and back again. So V double prime, let's see what we got. We start at -6, add 3 to -3, drop 6 from there to -9. The Y values, -4, -4 plus 1 is -3, and from there -4 is -7. W double prime. Now I'm starting with -3, add 3 to 0, subtract 6, -6, and 1, add 1 to 2, subtract 4 to -2. So that's transformation, that's the first transformation, my friends, called a translation or a slide. Peace.